Hello, I'm Simon Waite. I'm Senior Expert Materials at YASA. I'm going to briefly talk and provide an update regarding the management of alterations affecting composite parts and or structures. So why are we interested? Composites are not new. However, we've had extensive introduction of composites into particularly large passenger aircraft applications, for example, the 350 and the 787. This has introduced many in the supply chain to composites for the first time. However, industry expects to use these products much as they've used metallic products, and we need to be careful with that. It requires some consideration. You cannot simply assume that the practices cross over to composites from metal practices. The type cert holders have provisioned for some predicted mods, for example, provisions for antenna, but of course they can never predict how the industry is going to evolve. For example, within months of the 787 certification, YASA received applications for VIP aircraft with bespoke kitchen venting needs relating to the fuselage structure. So what is the scope of the issue? Well, we're talking about change to composite baseline structures, composite additions to metallic baseline structures, metallic addition to composite baseline structures, and composite additions to composite baseline structures. So this is the breadth of the scope of this discussion. So what examples are we talking about? There's a very simple one. It's the change of materials. This could result from a choice in terms of changing supplier, but it could be imposed by the result of other policy, for example, the REACH activities, which are removing environmentally and health and safety related materials from the supply chain. This changes your properties and requires review of your design. But obviously we are talking more distinctly about antenna, winglets, sharklets, interior structures, composite seats, bonded structures in general, and we even have to consider thoughts such as the addition of decals and vinyl wraps to aircraft, which change damage tolerance in terms of inspectability, damage generation, etc. So a reminder that regardless of whether you're engaged with the baseline structure or an alteration, the need to consider material is very high in the basic regulation. It's binding. You need to consider structure and materials which will be good for the operational envelope and beyond the operational expected life of the aircraft. Furthermore, this is wrapped up in the type design. The definition of the product includes the need to identify material and processes, and also fabrication methods. Obviously, the production activities may be changed accordingly. And then in the non-binding material, we have the CSs and guidance material, for example, CS 25603 addressing materials, which provides some high-level guidance to expectations. This applies to you as somebody changing a product. This is further backed up with guidance such as AMC 2029, composite aircraft structure. So composites are interesting materials. The properties are built into the part or the repair. This matters if you're in the user community, because you will now be generating these properties perhaps in a more challenging environment than the original manufacturer. So you need to understand them. Furthermore, the parts tend to be more complex. For example, we have reduced part count, which results in a more complex part. This is possible by methods such as composite material application. These processes are sensitive, and we have a challenge that these properties provide complications in terms of determining where you're driving your failure modes. What is the driven failure modes? Do you have competing failure modes? What are the engineering properties? Where are they defined in the pyramid? So this is a big challenge, and a lot of this information is intellectual property for many manufacturers, whereas a lot of the data for metallic structures and metallic materials exists in the public domain. One basic key regulation is CS 25605 fabrication methods. This basically requires that any process that requires close control be covered by an approved process specification. Perhaps more importantly, new aircraft fabrication methods must be substantiated by a test program. That's a big challenge for a lot of small companies engaged with alterations. Let's jump back to the basic regulation. We are now moving towards performance-based regulation. This is a higher level, more generic requirement set where we are looking for equivalence in terms of safety levels. In terms of practical management, we also have the associated recent level of involvement requirement, Part 21B100, where we're expecting to deliver certification effort in proportion to a number of parameters. For example, novel and unusual features, and that's novel or unusual to the industry and/or particular organisation. Furthermore, we're adopting proportionality in effort in proportion to criticality of the application. This is important. So, a quick example based on history. In the metal world, we have a long-established practice of accepting changes such as the installation of small antennas involving small penetrations of pressure holes. This is based on established practice. We've had simplified and established load calculation methods, use of readily available data in the public domain, common recognised practices relating to fatigue and damage tolerance, and further use of conservative factors. This has resulted in many decades of successful and safe application for metallic antenna. So when we consider repair or alteration to a composite pressure hull, we cannot necessarily assume that the same established practices apply. For example, if we consider the small antenna being applied to a composite pressure hull, if we think about the simplified load calculations, the anisotropy and variability of the properties challenges your assumptions about those calculations. The data that's available to you is probably much more restricted. It will be intellectual property, probably, for example, fastener allowables in a specific material for baseline structure will be unique to that supplier or manufacturer. We have to think about the assumptions that were made in the original design, for example, the damage tolerance assumptions, and what was substantiated in that original design, particularly if we are impacting baseline structure. And we've got to remember that a lot of these properties include key elements or considerations such as large notch data. This is fundamental to your understanding of what you can achieve or not achieve in such a situation. And depending on the material, you have these competing failure modes and different, ranging from brittle to ductile via quasi-brittle. So a lot of challenges if you're a small organisation without access to appropriate data. So recognising that this has been coming for some years, industry and regulator workshops were developed in 2016 and 2017. The outcome at that time was a draft AC from the FAA called Modifications and Alterations Affecting Composite Parts and Components. This was an extensive document intended to provide guidelines primarily for STC holders, design organisations supporting MROs, ETSOs, Part 1458 organisations in terms of perhaps a guidance document, perhaps better improving the understanding of what is achievable or not achievable under the scope of repair by replacement. It was also a document intended to provide a level playing field for the regulators. The content is much as expected. We have the usual subjects, including material properties, fatigue and damage tolerance, but importantly, there is an examples section which is quite extensive. It covers CS23 regarding camera with clamshell doors. We have several examples for CS25, that's large antenna and winglet installation. For CS27 we have installation of rotorcraft tail damper. So this evolving effort is tuned into the idea of proportionality for certification. So 4 levels of criticality have been proposed, noting that this is a draft document ranging from new and modified structure whose failure poses a direct risk to continued safe flight and landing, through to consideration of indirect risk to the airframe in terms of continued safe flight and landing, through to everything else. Accordingly, how we manage properties and material properties is stratified in a similar way. For critical structures, the consideration is again in terms of A and B basis data, which we are well familiar with. Then we move through less critical applications where we accept some level of point design, down to basically non-structural parts and non-critical parts where there's some acceptance perhaps of material manufacturers' data, application of unique detail testing, possibly similar to the higher level point testing. So again, the key point is stratification in proportion to criticality. Similarly, F&DT, fatigue and damage tolerance, this brings a potentially large threat to small organisations in terms of the limited ability to be able to produce extensive test work at a very high level in the test analysis pyramid. So proportionality is also stated here, where we propose perhaps some level of coupon testing, for example, open hole testing as a good way of gaining some conservative results in some situations. So this proportionality is reflected in this test set. If we look at an example, the large antenna, which is also discussed in more detail and more broadly than composites in another presentation in this workshop, we can look at how we can manage the extent of testing, coupon level testing, perhaps some cyclic testing may be required at the element level, perhaps some residual strength testing with various damage states applied to the part. But the important point here is the proportionality recognises the criticality of this application and potentially eliminates the need for full-scale cyclic loading for antenna and radome. So developing industry regulatory activities, the increased use of performance-based regulations is increasingly impacting the regulators. And the FAA Draft AC, which has been in existence for some time, is now to be developed into an SAE standard. The CACRC, the Commercial Aircraft Composite Repair Committee, has been tasked by FAA to turn this AC into a standard. This is the instruction with the objective making that point. And the intention is for this evolving document to be produced sometime in May 2022. So please be aware that you'll probably hear more dialogue in the open forum on this subject in the very near future. Thank you.